Hey there, Chem Scholars. Today we're going to talk about ionic compounds. Some more. We're picking up on the idea from yesterday. Okay? We're going to talk about the flip side. Yesterday, I gave you formulas. You wrote the names. Today, I'm going to give you the name. You're going to write the formula. And that's really a bit more of an important thing for us. Okay? Verbally, we tend to say things like carbon dioxide, water, ammonia, things like that. We need to be able to know what that means from a chemical point of view. Okay? So the idea really comes down to how well you know your ions, okay? Because it's really not a hard process otherwise. So let's take a compound like aluminum sulfide. Jump in right from there and talk about, all right, if I have that, how do I figure out the formula? Okay, so you need to know your ions, okay? Remember from the periodic table, aluminum is on that diagonal line, okay? Aluminum is always a +3 ion. So it's Al and it's +3. Okay, sulfide, that's part of, it's from sulfur, it's in column 16. Column 16 elements are always -2. Okay, so that's the hard part to an extent, as long as we do some basic math. Okay, now, we said previously that the total charge of a compound has to be 0. Okay, so +3, -2, that's not 0. The only way it's going to be 0 is if we find the least common multiple. Okay. Now I'll show you a shortcut to that. That'll work about 90 to 95% of the time. But let's just take that approach right now. So between 3 and 2, the least common multiple is 6. So I need to get the +6. I need to get the -6. Well, to get the +6, I would need another aluminum ion. And to get the -6, I would need 2 more sulfide ions. Right? Because here I have +6, here I have -6. So that means I need 2 aluminums, and I need 3 sulfides, and so my formula is Al2S3. That's all there is to it. Okay? Now, I said there was a shortcut, and I'll mention it. Okay? The shortcut is just kind of working off of these numbers and doing what they call a crisscross. Okay? So the fact that there's a charge of 2 here means there should be 2 aluminums. The charge of 3 plus here means there's 3 sulfides. That does not work 100% of the time. Let me show you an example where that would not work for you, okay, just to be clear. So let's do something like tin 4 oxide. Okay, so tin 4, whenever you have a Roman numeral, it's telling you the charge, so tin is Sn, it's got to be 4 plus. Oxide, same family as sulfide, column 16, so it's always 2 negative. Okay. Now, if you were to do crisscross, you would say that it's Sn2O4, but it's not. Okay. The least common multiple between 2 and 4 is 4. So I only need 1 tin, and I need 2 oxygens. So my answer really is SnO2. Okay. Now, you could say, oh, I just simplified. Yeah, but sometimes in ionic compounds there are things that are not simplified. Okay, for example, hydrogen peroxide is written this way, and I'll get into eventually why that is. Okay, potassium oxalate is written this way. Okay, you wouldn't want to simplify those. Okay, so you can't just say I'm always going to simplify. Least common multiple can't go wrong. Okay, crisscross, you could go wrong. Most of the time it's going to be okay, but you could go wrong. All right, so I'm going to switch views, go through a couple other examples there. Okay, this is just some of the information that we talked about. By all means, pause, and you can switch it off as you like there. Okay. All right. So here's an example: cobalt 3 oxide. So since it's cobalt 3, I know the charge of cobalt is +3. Oxide we just did is -2. Least common multiple between 3 and 2 is 6 again, just like the first example. So I'm going to need 2 cobalts. I'm going to need 3 oxides to get a total of +6, -6, giving me 0. And so the answer is CO2O3. Okay. Next example, magnesium iodide. All right, so I look at the chart. Magnesium is a +2, doesn't have a Roman numeral because it's always +2. Iodide, part of the halogens, okay, they always form -1 ions. So I have 2 plus and negative 1. The least common multiple is 2. So I only need 1 magnesium to get to 2, but I'm going to need 2 iodides to get to negative 2. So my formula is MgI2. Okay, chromium 6 phosphide. Okay, so chromium 6 is plus 6, Cr 6 plus. Phosphide, being in group 15, is always negative 3. Okay, so we have 6, we have 3. The least common multiple is 6. So I have 1 chromium that gets me to 6, but I need 2 phosphides to get me to negative 6. So my formula is CrP2. Okay, so that's really all there is to this part. That's it for today. Just going to go and do some practice stuff. Okay, let me know if you have questions. Ciao for now.